Hi, welcome and thanks for joining us this afternoon. I'm Sydney Bieber, Public Affairs Specialist at the Mid-Peninsula Regional Open Space District. Midpen helps plants, animals, and people thrive throughout the greater Santa Cruz Mountain region by preserving a connected greenbelt of over 65,000 acres of public open space. That's 100 square miles. Our missions can be summed up in 5 words: preserve, protect, restore, educate, and enjoy. And can you throw up the first slide there for me, Matt?
Yeah.
Great. Midpen is a unique public agency, a special district created in 1972 by a grassroots voter initiative to protect the green foothills of Santa Clara County originally. A few years later, San Mateo County voters expanded the district on the peninsula side, and then, in 2004, on the coast side. We manage 26 open space preserves with 245 miles of trails for you to explore free of charge all year long. And if you could put up the next slide for me, Matt. Each of the dark green areas on this map indicate a Midpen preserve. You can check out our website, openspace.org, for where to go, what you'll find out there, how we work to manage the land, and even ways you can enjoy nature at home, like through this and other virtual presentations. At Midpen, our Natural Resources Department is filled with dedicated scientists who help guide our land management. It's my pleasure to introduce Matt Sharp Chaney, a wildlife biologist. His focus at Midpen is on the wildlife within our preserves, and he has a deep knowledge of everything from mountain lions to frogs, and of course, the focus of today's presentation, bats, not mats, bats. So take it away, Matt, and I look forward to hearing about bats.
All right, excellent. Good afternoon, everyone. Thanks so much for joining us here today to talk about one of my absolute favorite subjects of all time, the winged wonders that are bats. And thank you, Sydney, for that great introduction. As mentioned, I'm a wildlife biologist with Midpen Open Space, and my focus is on mammalogy, or the study of mammals, including, of course, bats. So bats are mammals, just like us. They've got hair, just like we do. They're absolutely fascinating. They're often a little bit misunderstood. They're really remarkable in many, many ways. And today we're going to explore the many things that make them so unique amongst mammal fauna, how they support ecosystems, how they help people like you and me, what Midpen does to help protect and support bats in the Bay Area, and finally, what you can do personally to help bats yourselves. A brief disclaimer for anybody who is listening in with young children. We will be talking a little bit today about bat reproduction. We're not going to get into too extreme of a detail on that, but I just want you to be forewarned in case that's a sensitive topic. I'll give you another shout out when that information is about to come. Okay, so we're going to go ahead and start off with a little exercise so I can kind of get a sense for where people are coming from in regards to feelings towards bats and comfort level about bats. So go ahead and navigate to the website at the top of the screen, that menti.com. There's also a link in the chat that Sydney's posted. And you can either follow that link in the chat, or if you just go to menti.com, you'll have to enter in that code at the top of the screen, that 2028-0817. And just think for a quick second, don't overthink it. But just think for a moment and write the first word that just pops in your head when you think about how you feel about bats. Those probably take a moment to populate. So what we're actually going to do is revisit this at the end of the talk. But please take a moment and enter that information in there. And we'll look at this towards the end of the talk, and we'll be able to see what everybody said. All right, so let's move on to some bat basics. So what is a bat? Well, if you're a mammal, odds are actually pretty good that you're a bat. Bats, in fact, are the most specious mammal group of mammals on the planet. There are 1,400 species and counting of bats that exist today. So 1/5 or about 20% of all mammal species on the planet are actually bats. Bats showed up in the fossil record about 50 million years ago during the Eocene period, looking very similar to the bats of today, like we see on the screen here. And now there's still a bit of debate on what the closest relatives are to bats, but a recent study from the journal Nature found that they likely came from a group that eventually evolved into animals like horses, pangolins, whales, and even dogs, not rodents, as may have previously been suggested, or even tree shrews, which was another hypothesis. Now let's talk a little bit about bat physiology. So if you look at the image here, what you're going to be seeing is that, you know what, bats actually share some characteristics with us. They have hair or fur, they have arms, wrists, and fingers. You can see with that big, beautiful wing. But theirs, of course, are specially adapted for flight. In fact, the word for bat, the scientific word Chiroptera, for the group that makes up bats, means hand wing. And you can definitely see that there. Some features that bats have that we don't have, there's some obvious ones, including that elongated tail, wing membranes, which is actually composed of skin and muscle ligaments, and then that calcar, which is right at the knee, basically, or the bottom near the foot of the bat, which is a bony spur that kind of helps them to manipulate that tail membrane in flight. Next, we're going to show a quick video that highlights one of the most specialized skills that bats have, them being the only true flying mammal that can have powered flight. So sorry, flying squirrels, you actually only glide, which is still cool, but not quite as cool as what we're going to see this bat do in a moment. All right, excellent. Thanks for sharing that, Sydney. So that was actually a Pallid Bat being released from my hands at a bat workshop that I was attending a couple of years ago. Obviously, those in slow motion, so they're typically moving a little bit faster than that, but we wanted to give you a good idea of how they're able to fly through the sky in a way that's very similar to a bird, although a bit unique. So next, let's talk about echolocation. So this is another amazing physiological adaptation that bats possess. This is the ability to echolocate or navigate through their environment relying on sound. So you may have heard that phrase, blind as a bat. Well, that's not actually accurate. In fact, bats actually have way better night vision than humans do. Still, it's pretty tricky to get around at night and even trickier to track down insects in flight in the dark. So bats use a sophisticated method of producing a very loud, oftentimes, high-frequency noise to locate prey and obstacles in their environment. Now, in fact, some bats' calls are so loud, they actually have to essentially turn off their ears for a brief millisecond using small muscles in the middle ear to clamp down on their ossicles bone and deaden the sound when they call, to avoid actually deafening themselves. Their calls can be a remarkable 50 to 120 decibels, which is equivalent to basically holding up a smoke alarm kind of right next to your ear. So if you ever heard a smoke alarm going off, you know how loud that can be. Luckily for us, we can only hear frequencies of about 20 hertz to 20 kilohertz, and most bats' echolocation calls are at much higher frequencies than that. So believe it or not, this picture is of the same species of bat that we saw at the beginning of this presentation, that Townsends Bigeared Bat. But you might be wondering, hey, where did the big ears go? Well, they're actually tucked back behind the bat's wings because this bat is doing something rather remarkable. It's actually in what's known as a torpor. So its metabolism has slowed way down, its body temperature has dropped, Its heart rate is slowed, and so is its breathing. And bats do this when temperatures drop and when insect activities are low. The bats in our area are quite small, weighing around an ounce or less, and they have high energetic needs. Flying, of course, is really hard work, even when you're small. So when conditions aren't great for capturing lots of food, it's really advantageous to sit it out, basically, until conditions improve. And bats can do this for short periods of time, such as a few hours during a cold morning, or periods of months when hibernating in the winter. Not all bats go into extended periods of torpor, and some, like the hoary bat, which we'll look at later, will migrate thousands of miles to remain active throughout the year. All right, parents, with this adorable photo of this eastern red bat with 2 pups, which is the word for baby bats, I'm going to go ahead and start talking about reproduction. So for the next couple slides, we'll be talking about that. So now's the time to ask your kids to leave or go ahead and mute me if you like, just for a couple of slides. So bat breeding is a really essential thing to bat populations' relative health and survival of bat species. Now, breeding in our area, actual mating of bats, begins in September and continues through early November. Males use special calls to attract females, including little purrs, clicks, and buzzing. And bats begin to build up fat stores for the winter during this time as well. While breeding occurs in the fall, females, interestingly, don't devote energy to developing young until the springtime. So female bats in our area can delay fertilization by actually encapsulating sperm in the uterine lining and delaying ovulation until spring. So they do this because fall is often when bats are at their peak physical condition. Food has been abundant through spring and summer, so they have the energy they need to devote to breeding. However, winter is just around the corner, and spending energy on developing a young bat or fetus would not be advantageous to the female bat, nor would it be advantageous for that pup to be born in the winter when there's less food available and temperatures are colder. So from this point, bats go into a winter torpor. And then in the spring, bats become more active again and disassociate into male bachelor roosts, immature female roosts, and sometimes large maternity roosts filled with many, many bats. Interestingly, the bat that we see here, the eastern red bat, which is closely related to our local western red bat, don't typically form big colonies. Maternity roost colonies. They will roost individually with their pups in tree foliage. All right, so the maternity roosting season, when bats are actually caring for young, is from April 15th, today, which is why we actually chose the start date of this talk, through September 1st. So during this time, 1 to 3 pups are born per adult female, either in those solitary roosts like we saw with that eastern red bat, or in larger female maternity roosts. Males form what are called bachelor colonies to roost alone apart from these maternity roosts to keep from competing for resources that are needed by female bats to care for these pups. Pups feed on milk provided by mothers that are lactating from June through August. And in late summer, bats become volant, where they're able to fly and can catch insects on their own. And maternity roosts typically will break up and disperse by September. So the image we see here is of Mexican freetailed bats, and they're exhibiting a different strategy from what we saw from that eastern red bat. They formed a maternity colony, and these are really advantageous because pups all stuck together in one area, they can stay warm when they're gathered with other adults and other pups. This will help them to develop more quickly. Maternity roosts are typically stable, warm environments, and they look for temperatures between 85 and 105 degrees Fahrenheit, so quite warm. Now, images like these are possibly where the misconception that bats are like rodents came from. Now, if you came across this, you might think, this one adult female must have given birth to all these little baby pups that are around them. Well, in reality, she's probably only has one pup. And they can actually identify each other by the sound of their voices or the smell or scent of each other. And what's happening here is many of the adult bats may be out foraging, and there's a couple that are staying behind and watching the pups, looking out for predators and that kind of thing. All right, next let's talk a little bit about the actual bats that occur in the Bay Area. So we have 15 species of bats here in the Bay Area, believe it or not. And I'm happy to say, if you have any kind of concern about vampire bats, all of the bats that we have in our area are insectivorous, which means they eat insects. There are actually only 3 species of vampire bat, and they all occur in Central and South America. And very, very rarely do they actually feed on humans. So they're not even something to be concerned about if you are not living in the Bay Area. You're somewhere where vampire bats do occur. Now, many of the bats that we have in our area are what are known as mouse-eared bats or myotis. You can see that we have a variety of myotis species, and these guys are typically very difficult to tell apart. Oftentimes, these are called little brown bats. And the identification doesn't go much further than that. We also have some interesting special status species that are known as species of special concern. And this is a designation that basically means that they're being closely watched and monitored by Fish and Wildlife to try and understand what the population is doing and make sure that they don't end up in a situation where they need to become listed as threatened or endangered. So the 3 that we have here that are state species of special concern are the Western red bat, the Townsends Bigeared Bat, and the Pallid Bat. We also have other interesting bats in this area, including hoary bats, which are one of the hairy-tailed bats, silver-haired bat, big brown bat, canyon bat, which is one of the smallest species that we have, and the Mexican freetailed bat, which we'll talk about in a moment. Okay, so next let's move on to some local focal species so you can get to know a bit about the variety of bats that call our area home. So first off, let's talk a little bit more again about one of my favorites, the Townsends Bigeared Bat. Again, this is a species of special concern. These are cave roosting bats typically. So they'll roost in caves out in nature, or they'll also roost in structures, which are sort of analogous to a cave. And these are moth specialists. So they're going after moths and have an interesting approach where they're basically flying very slow and they're using very quiet echolocation calls. They're actually known as a whispering bat. So not all bats are calling really loudly like we talked about earlier. Now they're going after moths, and flying slowly and calling very quietly can be advantageous because some moths are actually adapted to drop out of the sky if they're hit by a loud echolocation call. So if you're ever out in somebody's back porch at some point and you're seeing moths flying around a light source, you pull out your keys and jingle them. That'll make a lot of high frequency noise. And if some of those moths are adapted to evade bats, they might just fall out of the sky. So kind of an interesting party trick. Now, the thing to know about Townsends Bigeared Bat is that they're extremely sensitive to human disturbance. And they'll actually abandon their young if they're at a maternity roost if disturbed too much. So this actually makes sense from an evolutionary standpoint. Townsends Bigeared Bats are actually quite long-lived. They live 16 years on average and can live up to 30 years. That's been documented for this species. And the oldest bat ever documented, just to throw that out there, is about 42 years old. So these are very long-lived species. Now, if you think about it, if you live 16 years on average, you've got all these different opportunities every year to reproduce. And if a threat comes along that might put you at risk, it makes more sense to abandon young and be able to reproduce later than to potentially get killed yourself. So it's really important when we know where Townsends Bigeared Bat roosts are to make sure that we limit disturbance as much as possible. All right, moving on to the next local focal species, we have the Western red bat, closely related to that Eastern red bat we saw earlier. This bat is a solitary foliage rooster that can be found roosting up in the leaves of trees in riparian areas with cottonwood and sycamore trees. This is, in my opinion, one of the cutest bat species, and it also happens to be the first bat species that I had a close encounter with. I found a Western red bat while I was riding my bike in Santa Cruz when I was a kid that had been struck by a vehicle. and was down on the ground, and I was able to get a close look at it, which I'll never forget. Now, these are kind of super parents. They can have up to 3 pups at a time. And they also feed mostly on moths, but they have a different strategy. They actually have very strong straight flight patterns and are not super maneuverable. So they're catching moths at higher up elevations above the canopy. And they're capable of covering very long distances and have even been seen out to sea, several miles out to sea by people in boats. All right, another great species to talk about here is the Pallid Bat. This is another large-eared bat, but this one, interestingly, is mostly hunting on the ground for ground-dwelling insects like Jerusalem crickets, katydids, and even, as we see here, scorpions. So they have an interesting musky smell, almost like a skunk, that's thought to help them identify individuals in a roost. They also have very large eyes and a very prominent nose, along with those big ears. And this is all helpful for them in hunting ground-dwelling insects. They're using all of the senses that they have available to them to locate these insects, including echolocation. And when they do find something that they want to go and eat, they'll actually land on the ground and wrap their hands around it and basically corral that insect in towards their mouth, which is kind of a cool strategy. All right, next we'll talk about the Mexican Freetailed Bat. And despite the name, the Mexican Freetailed Bat does not just occur in Mexico, it occurs all through North America. They are a common species, but ecologically speaking, it's important to note, the common species, just because there are simply more of them, they're doing a lot of the heavy lifting. They're eating more insects, they're spreading more nutrients through their droppings, they're doing a lot of ecological work. So this is one of those bats that you're most likely to see. In fact, there's a very large colony at the Yolo Bypass north of Davis, and these are crevice roosting bats. So they like to roost in tight little crevices, like many of those Myotis species we talked about earlier that are also crevice roosters. These bats are high and fast flying. They have long, thin wings and a tail that protrudes past the membrane to help with maneuvering. Their ears are connected together by a really strong crest right above the head, and this helps with aerodynamics. In fact, believe it or not, Mexican Freetailed Bats are the fastest mammal on the planet and can fly up to 100 miles per hour. Now, why should we care about bats? Well, it's often been said that if you don't like mosquitoes, you should really, really love bats because a single bat can easily eat 1,000 mosquitoes per night. This can really help with lowering that pest species population number. Now, of course, aside from helping us by eating mosquitoes, they're also really essential part of a healthy ecosystem. They regulate those insect populations. They spread nutrients through their waste, which helps plants to grow. And they are themselves a food source for species like hawks, owls, and falcons, and even things like raccoons. They also eat agricultural pests. And according to Bat Conservation International, the annual insect control that bats provide is worth an estimated 23 billion with a B to US agriculture. So they are our natural insecticide. Now, bats also pollinate plants, like this Mexican long-tongued bat, which doesn't occur here in the Bay Area, but I did want to talk about the benefits of bats, and pollination is a big one. They, in fact, pollinate plants such as the blue agave, which is famous for producing the drink known as tequila. So if you happen to be a fan of margaritas, or you just like the idea of plants being pollinated by bats, that's another good reason to care about them. Bats are also culturally important. We've got Bela Lugosi here as Count Dracula, famous folklore of a man that's able to turn into a bat that drinks blood. Now, this is not my favorite portrayal of bats personally, but it's a culturally significant one. I'm actually a bigger fan of this Zapotec bat god from the region that is now known as Oaxaca, Mexico, which is thought to have been an important emissary to the underworld and the spirit ancestors of the Zapotec peoples. Note that prominent kind of horn structure on the forehead. This is very likely a representation of a nose leaf, which is a feature found on certain bat species from the area that eat insects and likely play a large role in agricultural production in that region. And of course, I would be remiss talking about bats without mentioning the Caped Crusader, Batman. Of course, Batman is trademarked, so I can't show you a real image, but here's my knockoff version featuring me in my last Halloween costume. And I actually really like Batman as a representation of bats because Batman is the world's greatest detective. And DC Comics, in fact, actually stands for Detective Comics. Yes, I am a nerd, believe it or not. And bats are really highly curious creatures. They're always investigating their environment, much like a detective. And the reason for this is that they need to know what areas that they can roost in. So if conditions change or a roost is destroyed, they've got a backup that will support them. And while bats, as far as I know, don't fight crime, there's at least some similarities between them and the famous Batman. All right, that's a good kind of lighthearted way to transition into a more serious topic, which is threats that exist to bats. So one of the #1 threats to bats is one that many species are facing, and that is habitat loss. So just like most of us here in the Bay Area can really relate to there being a housing shortage, there's also a housing shortage for bats. So if we look at the graphics from this study shown here, there's a couple of things being shown, and that's in the study area between 1930s and the year 2000, the actual number of trees per hectare increased. So that's a good thing, right? We want to see more trees. But interestingly, if you look at figure B, you see that the actual basal area, so the size of these trees, has decreased significantly in that same time period. Now, smaller trees are less complex. They have fewer hollows and exfoliating bark or woodpecker cavities that can support roosting bats. So we want older, old growth, complex trees to support bats to the best extent possible. All right, so we talked about there being a housing shortage. Well, there's also a food supply shortage that bats are dealing with. In this study, there was found to be a 41% decline in all insect species included in this study. So that doesn't mean that 41% of all those insects are gone. It just means of the species studied, 41% of those are in some form of decline. So I just want people to be aware because it looks very alarming if you just think 41% have dropped. But this is still an alarming trend and something that is worth keeping an eye on and thinking about. Now, basically, the causes for these declines are a variety of factors, including things like, again, habitat loss, insecticide use, as well as factors associated with climate change. Another big issue for bats is a disease known as white nose syndrome. Now, this is caused by a fungal pathogen known as Pseudogymnoascus destructans, or PD, that impacts hibernating bats. This fungus does really well in dark, damp caves and impacts bats during their winter hibernation period when they often gather in large groups and then the pathogen is able to spread. This grows on their noses, their faces, and their wings, and it awakens them from their hibernation, causing them to rub at their faces and try to get this fungus off of them. So this is a sensitive time for bats when they have limited fat stores, and every bit of energy expenditure lowers their chance of survival. So this is actually thought to be one of the more destructive wildlife pathogens that have ever been recorded and can wipe out up to 90 to 100% of bat populations in areas where it occurs. And unfortunately, white nose syndrome is on the move. So this map from the United States Geological Survey shows the spread of white nose syndrome, which unfortunately showed up in Lassen County in California in 2019. Now, humans may actually be one of the main vectors for spreading this disease, as spores can contaminate and persist on boots and clothing. So when people hike in or near caves and then move to other areas with the right conditions for the fungus, it can then take hold in new locations. So if you happen to be into spelunking, hey, I'm with you. Caves are amazing, but it's just really important for us to decontaminate our equipment before we go into caves and after visiting a cave. And you can find out more about white nose syndrome, including appropriate decontamination protocols and some of the links that we'll share at the end of the talk. Now, collisions with wind turbines is also a leading cause of bat mortality in the US. Luckily, there are many researchers out there that are working on innovative solutions, including adding audio and visual deterrents around wind farms to keep bats from colliding with these turbines. Now, these innovative solutions can help to keep bats safe while supplying much needed energy alternatives that can help combat climate change. And finally, one of the biggest threats to bats is really actually public perception. So many of us have heard that the SARS-CoV-2 virus, which causes the disease COVID-19, may have originated in bats. And this is certainly a possibility, but it has not yet been confirmed. No bat anywhere in the world has tested positive for COVID-19. Bats, in fact, have some really serious superhero immune systems. This maybe has to do with their incredibly long evolutionary history. But they have the ability to carry many different viruses without suffering illness. In fact, bats may hold the key to understanding how to develop treatments to diseases caused by a variety of viruses. And the real issue here isn't that bats may carry disease. All wildlife has a chance to carry disease. People, of course, can carry disease as well. It's that bats' habitat is disappearing at really alarming rates. And this can bring bats and people into close proximity. In addition, in some parts of the world, bats are an important food source and might be kept in close proximity with other wildlife, which would be the perfect environment for viruses to jump between species and even potentially jump to us. But you might be interested to know that during the COVID-19 pandemic, bat research that involves holding bats in the United States has actually largely stopped. Not because researchers are worried about getting COVID-19 from bats, but actually because we're worried that people might give COVID to the bat population here. So this is a good reminder for us that disease transfer is a two-way street. All right, so this brings me to my next kind of nuanced point, which is that, I don't want you to be terrified of bats or afraid of being near bats, but I do want you to definitely know it is not okay to touch bats. Really, don't touch any wildlife, because doing that might put you and the animal at risk. So if you find a bat on the ground, contact your local vector control, or if you're on a Midpen preserve, go ahead and call the number listed in the slide here. And then somebody like myself that has a rabies vaccination can come out and safely remove the bat and relocate it to a wildlife rehabilitation center. Rabies is a very serious disease. It has a near 100% mortality rate. Luckily, you actually have to come in contact with saliva or blood from an infected animal to get this disease. So the easiest way to avoid that risk is to just never touch an animal that may carry the virus. An average of just 2 people a year contract rabies from bats in the United States and Canada. So the risk is exceptionally low as long as you avoid touching bats and other animals that may carry rabies. So again, I don't want you to be afraid of being around bats. To emphasize that point, many of you might be familiar with this famous bridge in Austin, Texas, where there's a huge colony of Mexican freetailed bats that emerge every evening. And as you can see in this photo, there's a lot of people right near these bats as they're flying and coming and going. And it's okay to look at bats from a safe distance and appreciate them and have a nice experience seeing them in real life. And that's not a danger to just have them near you. But as long as you're not touching them, then that's perfectly safe. So how do we study bats at Midpen? Well, some of the more simple surveys, of course, is just trying to find out where they are. So sometimes it could be pretty obvious, like, hey, we've built a bat box. Are there going to be any bats in that bat box? But sometimes it could be a little more difficult, like if they're roosting way up high in a tree, in a hollow, or in the foliage of trees. But yeah, we want to know where bats are so we can help protect them. So this involves basically looking in appropriate habitats for evidence of roosting bats, like urine staining, guano, pieces of insects, cold insect parts, or of course the bats themselves. But it's important to note bat use in habitats fluctuates quite a bit throughout the year and even at different times of the day. So you might not see any bats during the day, but they might be coming in at night, or vice versa. You might have a roost that is active during the day, but at night the bats leave. So you want to make sure that you're surveying at different times under different conditions to really get a sense for use. So this makes it really important to check different roost habitats all throughout the year instead of just at one time of the year. So how can you tell if you're looking at something like bat guano versus rodent droppings? So quick disclaimer here, I'm definitely not advocating that you go out and touch poop. But if you're a biologist like me, this is something that you might have to do on occasion. So what we'll do is we'll go out, we'll put on a latex glove, and we'll do what's called the smear test. So we'll take our finger, push down on the guano, and kind of push it across the surface and see what it does. So if it flakes apart, like we're seeing here in this image to the right, then it's likely a bat dropping. What we're seeing is all of these little bits and pieces of insects that are flaking apart on the dried dropping. Now, if it was something like a rodent dropping, which is made up of a lot of fiber and vegetation materials and glutinous materials, that dropping will probably just roll across the ground and stay intact. So that's a way that we can tell what we're looking at. Now, another way that we study bats is through acoustic monitoring. So we have two types of acoustic monitoring that we use. One is active acoustic monitoring, where you get to cosplay as a Ghostbuster, like my friend Karine Tokalian is demonstrating here. And this allows you to get bat data in real time. So as the bat's flying above your head, you're seeing what it's doing and what those acoustic calls look like. The other method is using a passive monitoring setup. So you put a microphone out with a battery bank and a recording unit, and you can leave these out for weeks at a time and then come in and collect that data. So the trade-off is you get a lot more data, a lot more understanding about what bats are there, but then you have to spend more time, of course, on the analysis. And there are different situations where either method is more appropriate. So this is what acoustic data actually looks like when we get it. This is using a program called Sonobat. There are many different programs that people use, but this is the one that we have. So what we see on the vertical y-axis is kilohertz. And on the horizontal x-axis, we see milliseconds. So, and the bright colors that we see correspond with the intensity or the volume of the call on the recording. And each species of bats have a set characteristic echolocation call. And we can look at comparing recordings of identified calls to identify bat species within a certain degree of confidence. So for example, this call here has been analyzed as belonging to Eptisicus fuscus, which is the big brown bat. Different bats, of course, have different characteristics and frequencies, but that's what this one is. So it can help us to identify the species themselves. Very, very useful. And then other interesting things that we can learn from these recordings are just what the bat's doing as it's flying through the air. So here you might notice we've got that really bright color on one call, and it's a little less bright in the next call. And then it's a little bit more bright, a little less bright. So what we're seeing here is actually a bat flying through the air, and we've got a microphone set up. And as the bat flies, it's actually moving its head from side to side and calling. It's not just keeping its head facing directly forward. It's really kind of looking around and calling and getting information from all angles. So what's happening is the bat is looking towards the microphone and calling, and we get that loud signal. And then it's looking away from the microphone and calling, and then we get that quiet signal, which is kind of cool. Another thing that we can see from these recordings is that the frequency of those calls, how many calls they produce in a specific period of time may increase or decrease. So we see here at the beginning, calls are sort of more spread out. So that is a bat that's in a search phase. So it's flying around, looking around through its environment to see things that might be interesting to it. And then all of a sudden, we see the calls getting a little more frequent, increasing. So what's happening here is that bat has likely seen something that is of interest to it in the environment, and it's sort of locking on. So it's calling a little more frequently. And then it'll enter what's called the terminal phase, which I don't have an image of, but basically those calls get closer together still and become incredibly rapid. And that's when it's just about to find and grab an insect out of the air. So it's getting more information in as it approaches that insect. So next I'm going to go ahead and play some calls for you, so you can hear what these sound like. Of course, the calls, the frequency of the calls has been decreased so that we can actually hear it. But first I'm going to play a time expanded version that will slow down the call as well so we can hear individual calls. And then I'm going to play it in real time so you can hear how fast these bats are calling as they fly throughout their environment. All right. And this is a Myotis humanensis, or a Yuma Myotis species recorded in Santa Cruz. All right, so that was the time expansion version. And then I'm going to play it in real time. And that was the same call that we heard in the time expansion in real time. So these guys are calling just incredibly quickly as they fly. And oftentimes the call is actually synced up with the speed of their wing flaps, which is kind of interesting. All right, so in some circumstances, that acoustic data might not be enough to answer the questions that we have about bats. So if we're interested in things like demographics, you know, how many old and young bats there are, what the sex ratio is, what bats are eating, if there's a maternity roost in an area, which can be really important, then we might need to do what's called mist netting for bats. So here I'm at a workshop, we're setting up a large mist net, and these nets have very fine filaments that are difficult for bats to see. And we'll place these in areas where bats are likely to fly through that have sort of pinch points in the environment that funnel them into the nets. And if we're lucky, we might capture a few bats. So as you can see, these nets can be very, very large. This one right here is 20, 30 feet high. Which makes them difficult to avoid. So it's not that the bats can't see them, they can detect them, but by the time they do, they don't have much chance to maneuver and get away from them. And oftentimes they'll end up in there. And once we have a bat in the net, we very carefully extract them. And we do our best, of course, to minimize stress to the bats throughout this process and minimize any handling time as much as we possibly can. And once we have these bats in hands, you'll notice we're always wearing gloves when we're handling bats to keep them safe and to keep us safe. And when we have them, though, we can get some really interesting information. So we can take measurements, we can determine the age, which is actually what I'm doing in this picture here. This Pallid Bat wing is being illuminated by a colleague's flashlight. And I'm actually looking at essentially the knuckle bones in the fingers of this bat. And I'm looking to see if the light from that flashlight shines through that bone. And if it shines through, that means that those knuckle bones are not fused yet. So we're likely looking at a younger or juvenile bat. If it doesn't shine through, then that means the knuckle bones are fused and we're looking at an adult bat. And then we can do measurements and look at the forearm length, and we can look at the length of the tragus, the ear length, things like that. And this can be helpful to us in just understanding, general morphology of the bats in the area, but also can help us to identify bats to individual species. We can also weigh bats by wrapping them up in a little piece of nylon and making like a little bat burrito. And then we weigh the bat in the nylon and then weigh the nylon without the bat and subtract. Then we know how much these bats weigh. Here's one of those one of those Quarry Bats that I mentioned earlier, another really cool looking bat. Credit to Paul Haggard on that, and shout out to my friend Bethany Schultz, who's done some really great research on Quarry Bats. And here, I'm not actually blowing kisses to this bat. I'm actually blowing air on it to move the fur so that I can get a better look at the nipples on the bat and determine if the bat is lactating, or if it's a female, if it's had pups in the past. So bats have really sharp teeth. Bats in our areas that are all eating insects need those sharp teeth. But when they're nursing on their moms, they can actually leave some pretty serious scarring on the nipples. But this could be a great way for us to know if we're looking at a mature bat, because we can see, hey, has it had pups in the past? So next we're going to talk about how Midpen helps to protect bats. Now, the most important way that we protect bats is actually, of course, through preservation of habitat. And I'll talk a little bit about work we do that's associated with man-made structures as well, but the most important habitat for bats comes from healthy ecosystems that provide structure for bats roosting, usually outside of man-made buildings. That varies a bit from species to species. There are some that do really, really well in man-made structures, like Mexican Freetailed Bats and Yuma myotis. But many others rely on natural habitat. So that having been said, here's a few of the projects I'd like to highlight. These are some large cinder block bat structures that were designed by Dave Johnston and Kim Briones from H.D. Harvey and Associates to provide roosting opportunities for both crevice roosting bats and cave roosting species like that Townsends Bigeared Bat. Huge shout out here to our Midpen crew who built these structures out at Bear Creek Redwoods to give bats a place to roost following the removal of some of the structures at the former Alma College. Here we have one of the historic structures at Alma College that was not removed. In fact, it's been maintained and modified as part of our cultural preservation in the area, but also to support bats. So this is Cody Fix and Dave Johnston. Cody's one of our crew and Dave is from H.D. Harvey. These guys were both instrumental in this work. And our crew went in and with the design from H.D. Harvey, worked to seal off these structures with cinder blocks, creating a really nice, warm, cave-like environment for bats. And we also have crevice roosting structures. You see bat boxes on the exterior of the building and some on the inside as well. And they even put up corrugated metal sheeting to block light from entering inside the building to keep it nice and dark inside. And we have entrances that the bats are able to come and go through. So we're going to continue to monitor these structures to see how bats are using them. And I'm happy to say that recent surveys have detected bats using this structure, including one of our target species, the Townsends Bigeared Bat, which is really great. So along with monitoring for bat use, we're also paying attention to the temperature inside of these structures, making sure that it gets to the right heat during the summertime to support maternity roosting. And we can make adjustments if needed to try and make it warmer or cooler in there. Another interesting component of this project is that we've used a bat lure that actually plays the social calls of bats. Bats aren't always just echolocating when they're calling. They can also use social calls to talk to each other. And we typically can hear social calls because they're not as high frequency as those echolocation calls. But basically this speaker system plays social calls and encourages bats to come and investigate these new structures that we've created for them. As far as we know, bat lures haven't been used for this purpose, but they have been used successfully to bring bats into mist nets so that they can be more easily captured. But we haven't heard anything about using it to bring bats in to colonize new areas. So if successful, that could be a big benefit for other projects that might be trying to do the same thing. So I'd like to kind of conclude now in talking about how you can help bats. So here we see a big brown bat roosting in just a half-inch crevice, which is like the perfect spot for them. They love that kind of thing. And if you're a homeowner, you may have had bats take up residence in your home in situations like this. And you might not be so keen on that, which, that's understandable. But, if you are not so keen on living close to bats in this way, I just really have to advocate, just try to avoid removing bats during those sensitive periods. So the winter torpor and the summer maternity roost season. And if you are going to contract out with a company to remove bats, try to make sure that they're not utilizing lethal removal strategies. They're using non-lethal strategies to safely let the bats leave on their own and then seal the structure so that they're not able to come back. Another thing that you can do, of course, is to actually provide habitat for bats. So maybe you don't want bats roosting right in the walls of your house, but you'd like to have them around so that they can keep mosquitoes down and maybe even make some nice fertilizer for your garden. So if you're interested in that, you can put up something like this, a nice bat box. There are many companies that make these. There are also designs that you can download and you can make them yourself. Be a really cool woodworking project. But you can put these either on the side of a house, or if you don't want them quite so close, you can mount them on a pole and put them a little bit further back away from your house if you'd like. And this would be really great. This can help with that housing shortage that bats are dealing with. Now, of course, like I mentioned, it doesn't have to be man-made structures. Another things that can support bats is to plant trees. And if you happen to have property with a lot of acreage on it that has maybe some older snags, dead trees that have a lot of cavities and exfoliating bark, try to retain those if you can, and if it's safe to do so, because those are going to support bats more than live trees often can. If you are able, if you have the privilege to be able to afford organic foods, try to purchase those and that way we're cutting down on insecticide use and helping with that food shortage that bats are dealing with. And then you can also follow and support organizations like Bat Conservation International and the Merlin Tuttle Institute. But lastly, and I can't emphasize this enough, most importantly, just talk to your friends and your family about bats. What makes them so great, what makes them cool, what makes them fascinating, and just become a bat ambassador. Help spread the understanding and dispel misconceptions about bats. And that's probably one of the most important things you can possibly do to help them. So with that, I will conclude my talk. As you can see, and I'm sure you've noticed, I really do love bats an awful lot. I hope you've learned something about bats today. And if you'd like to know more, there's a ton of great information on the websites posted here from Bat Conservation International and the Merlin Tuttle Institute. And before turning it over to questions, I'm going to go ahead and see if our word cloud has populated. I'm not seeing the words popping up here. So I'm going to go ahead and leave it, and we can talk about that later when we do some follow-up emails and surveys. But yeah, I will turn it over now for questions.
And actually, I can share the word cloud. We did get, I think it looks like 24 responses, and we'll share later as well. But it looks like a lot of those responses are, some are what you would expect, but there's love and mysterious and fascinating, and that's all great information there. And we have some questions that have come in, so I'm going to share some of those. And the first question, I think, was, do we have any confirmed special status species on Midpen properties?
Yes, absolutely. Yeah, so I talked a lot about the Townsends Bigeared Bat, and we have confirmed Townsends Bigeared Bats roosting on several different preserves, including Bear Creek Redwoods, where we've built those structures that I mentioned earlier. We also have a known colony of Pallid Bats, a maternity roosting colony in La Honda, that, as far as we know, is the only maternity roosting colony on the peninsula for that species. So potentially very regionally important for that species of bats. We also have detections of western red bats throughout the district, but they are typically not breeding here in the Bay Area, but they still do migrate through the region and spend some time here.
Great. And I have another question. What can I do to give, and this comes actually from a former employee who has moved far away to cold lands. What can I do to give bats a place to hibernate in the winter in a cold climate? Do bat boxes need to be heated?
Oh, that's a really good question. Yeah. So they don't need to be heated. Basically, what bats are looking for when they're looking for a winter hibernacula is somewhere that's going to be very stable. So a nice enclosed space. They often do end up going into caves or buildings to find this. They don't want something that has a lot of airflow through it or a lot of access from animals or people that might disturb them when they're in their hibernacula, which is just a place that they hibernate. It's a fancy word for that. But yeah, bat boxes can definitely support bats in a torpor. But also, larger structures, large trees that are a little bit more complex can be a great place for bats to go into a hibernacula.
Great. And bat boxes seem to be a popular subject. Someone's wondering, how high should bat boxes be placed? And this is great that people, are interested in seeing how they can help bats in their own neighborhood.
Yeah. Oh, yeah, absolutely. So like I mentioned, Bat Conservation International has got a lot of great detailed information on that. But typically, you want the bat box to be anywhere from 10 to 12 feet high. And this basically gives enough of a drop underneath that box that a bat that's flying out can gain lift and get up into the air. Just as a kind of fun aside, I've seen in late summer young bats that are from that year's reproduction, that cohort of baby bats where they're just learning to fly. And right underneath the bat box, they were coming in the evening or in the morning rather from their night of flying around. And that they're a little bit clumsy at that point. And they're basically like bouncing off of this bat box and landing on the ground and then climbing up into coyote brush and trying to fly again and get up in there. So yeah, having a good amount of space underneath the bat box is really great. And then just making sure that there isn't a lot of clutter around it either. So there's not a lot of trees and bushes and things like that can obstruct their flight path.
Great. And another question, how many species of bats will roost together? Is there competition as in cavity nesting birds that occupy boxes close together?
Yeah, that's another really good question. I have seen several species of bats in the same roost. So I've seen roosts that have Mexican freetailed bats, myotis together very often. I've even seen big brown bat and myotis and Pallid Bat in the same type of roost. So they typically don't tend to be super hyper aggressive from what I've observed anyway, and will roost together under certain circumstances. But I've also heard that bats can be pretty territorial when it comes to areas where they're feeding. And interestingly, I've heard from some other researchers that have actually witnessed bats get into it and basically fight each other off when they're foraging in the same area.
Wow. And someone else is asking, what should I do if I see a bat on a hike in a Midpen preserve?
Yeah, so if the bat is just out and about and flying and looks good and healthy and there's nothing concerning, I'd say just keep your distance and enjoy the rare opportunity to see a bat in person. Now, of course, if the bat seems like something's wrong with it, if it's on the ground, as we mentioned earlier, definitely don't touch the bat. But you can call Midpen and probably me, I'll come out and make sure that we do what we can to safely relocate the bat and get it to a wildlife rehabilitation center if that's necessary. Great.
And it looks like we're coming to the end of our presentation today. And I wanted to thank everyone for coming out and learning a little bit more about bats. We have a survey that we're sending out to everyone who registered, and I've also just put the link here in the chat. So if you could give us a few minutes to let us know what you thought about today's presentation, it'll help us in developing future virtual events to present, and let us know a little bit about what you learned about bats today. So that's important to us. And thank you so much for joining us. I'll also put a few more links in the chat. Visit openspace.org. We have a lot of information about bats, other wildlife. This presentation is being recorded. It'll be available on our YouTube channel as well as on our Facebook page, and we will post it on the Midpen website as well. And thank you all for coming out.
Have a great. Thanks, Sydney. Thanks, everybody. And yeah, if you have any additional bat questions, feel free to send us an email at info@openspace.org, and we'll try to answer those for you. Thanks.
Thanks. Bye.